typically we don't like to recommend people doing a lot of stuff, right? Because people are expensive. There's build state errors. There's things of that nature. But in all these conversations about automation, robots, human-like robots, humans are incredibly well suited, right, to do a lot of this stuff, especially like simple, but I want to say like simple, but complex, repeatable tasks. Sometimes robots are not well suited for that, right? They're suited for very simple, dumb, high, like weight, tasks, things of that nature, depending on the size of the robot or the automation you're using. And you'll often see, for low end vehicles, somewhere in that 5,000 unit range, like we'll take apart stuff and, or even see videos later of maybe something being assembled. I'm like, oh wow, this entire door panel is fastened together. And not only is it fastened, it's not even like a multi-head nut runner, right? They're just like, nope, it's a guy with a nut runner, So, and he's going through and just doing these 37 screws. But they only build, 3,800 a year or something like that. So have you kind of, from that perspective, have you always thought, because in our mind, at a certain point for scaling, you want to change manufacturing methods to get volume, but are you always shooting for, we plan on building this amount of volume of bikes, maybe not a ton more, or maybe if we get that successful, that's a separate problem for us in the future that we need to build,
Yeah, yeah.
tens of thousands of bikes. So how did like that, since you've come in with almost like the garage assembly mentality, is there a threshold there that you guys kind of discussed initially that's helped further scope the project?
Yes. And obviously, for me and for us, this is not really a niche product that we're going after. This is a mass scale product at some point, right? And whether that involves automation is something that we've thought a lot about. And I actually don't think it's. I think there's certain things you have to design specifically for automation. And our thing was actually we thought let's build some of that out. Like let's figure out how we can do without some of the complexity that requires automation. Like I think welding is a big thing. Welding, it's hard to find a really good welder that does it very consistently all the time, right? I think then you end up having to get robots to get into scale. So we designed out the welding. Like our frame, our entire frame, actually our entire bike has no welding whatsoever. Everything is actually either riveted, fastened, somehow fastened together, right? And so the entire bike, and that obviously comes with a lot of challenges because motorcycles are not really done that way. Most frames are welded. It's
Correct. Yeah.
fixtured and it has. But for us, that was the complication, right? There's a lot of cost in fixturing. There's a lot of cost in welding. There's a lot of cost in robots. So if we are able to build that out of it, we can always automate how the parts come together, or we don't have to, right? It allows us to kind of scale up and down very quickly. And that's super important for us as a small company. We don't have unlimited capital, right? So we're always looking at how do we scale with demand. Okay, let's say we sell 100 bikes this month. We need to be able to do that this month without having a bunch of people sitting around the next month if we don't sell that, right? So it's super critical. And this was the only way that we saw that happening. Now, the movement that we're seeing in the humanoid space, that's super interesting, right? Because you can kind of see, okay, instead of having a person, we can automate the person, which I think is really great for any task, but specifically for what we're doing. We optimize the process for very low skilled labor, which is also very critical, right? It goes all the way down to how we do work instructions. And we took the IKEA approach, right? The work instruction has to be visual. It has to not involve a lot of text or any text at all. Like if we were to go over in Southeast Asia and we built over there,
sure,
we want to be able to train new people how to put this frame together without complex instructions to kind of minimize the any mistakes.
Sure. So, visual build sequence.
Yeah. So that's really important. So the entire frame and structure of the vehicle of the motorcycle is optimized around simplicity in how the thing comes together and how you service it and all of that, right? So it's not just on the manufacturing side. We looked at, okay, we don't have a dealer network. What happens when this thing breaks down?
Right.
how do we do rights to repair and be able to show people how to take this thing apart and actually work on it, right? That was one of the big ethos of Ryvid. And so the entire vehicle is kind of designed around that. And it's hard to show you without visuals, but
Sure.
I, I have a frame right out here. Can I grab it real
Yeah,
quick?
please. Yeah.
All right. So here's the actual frame of the bike, right?
Yeah.
And it's cool because it's 3/16 stainless steel.
And it looks like it's all break bent and like laser cut.
It's all break bent. Like the
Yeah.
whole thing is laser cut. It has we cut all the holes. We put PEM nuts in there so that there's no loose fasteners anywhere,
Sure.
right? So the whole thing is self-contained. It's consisting of about 4 parts that kind of goes together, just with a rivet gun and a few fasteners where it's really critical for structure.
Yeah.
In the end, we ended up with this super strong monocoque structure that's essentially fastened together in a box structure,
Right.
And the head tube, we had to kind of figure out, man, how do we not weld a head tube? Because every head tube's welded, right?
Sure.
It's going to move around over time. And so that alone took us time to figure out because it hasn't been done before. So we're like, okay, let's figure that out. Let's figure out how to mount the swing arm, the drivetrain. And so what we ended up with was essentially we're able to do production, and I may be getting ahead of myself here, but we do production in parallel. Like we call it parallel production because it's not a line where you do one thing then you wait for the next. We have 6 sub-assembly stations with 6. Your frame is one sub-assembly. Let me bring in another one here. I'll show you. Okay, this is cool. So this is actually our rear drive unit. It consists of the motor, right? The 2 die casts for the swing arm, and everything comes in as one unit, right? So you end up having there's 5 subframes, 5 substations. You got your frame, your motor, drivetrain, and then you have your battery as a separate thing, and then you have your headlight units, your tail light units, and your seat. And they are all just constantly being made by a team of 6 guys.
So they're being built offline,
offline,
and then being fed to. Is it like a stationary? So you don't necessarily have a production line where the bikes are moving down. There's stations, and all components are coming essentially line side and being built there all the way up. Okay.
Exactly. And that allows us to keep building sub-assemblies without having to build final motorcycles.
Right. No, I mean, you had mentioned an interesting point, right, about cycling product to demand and then like idle time. And that's something I think to this day, and I see it in like numerous forums and things like that, where people are like, how can we keep talking about chipsets and quality problems associated with COVID, and the shutdowns? And I don't think people realize just how wide those ripples of shutting that plant down and certain things shutting down for a long period of time. And one of the unfortunate side effects of that is many of our customers, some of their best labor just left and they went to different industries, right? Because they couldn't essentially deal with like coming on and off. Like, I'm on for 2 weeks and then I'm unemployed for 2 weeks. I'm on for a week and then the plant's idled again because we can't get some chipset for this. And so they lost a lot of people, and then they end up using a lot of temp labor. And then regardless of what happens, some of these shortages, that's it. Since it's a production line, if you can't build some configuration, it stops everything, right? And when you idle that entire line, like some of our customers have lines that you don't even want to bring up idling because it's like a money printing machine. Like the moment some of those plants stop moving and you have to make a phone call from that plant and said, if we have a problem and this doesn't move right now, you're like, this pays for everything, right? It's a very, all of our future development, everything hedges on a particular plant, or series of them. But there's some of these things that are very, very, what they build there are very high profit margins, and they are bankrolling all future things, right? So, it's really no surprise that essentially certain ICE trucks pay for everything, So, and when someone makes a call and says that this production line is stopping, there's a problem. So that's pretty interesting. I mean, I think if we showed that to Sandy, he'd freak out about all the fasteners because he doesn't like
Oh,
fasteners. But
yeah, it's funny because I'd love to show them actually because it's the fasteners are, we only use fasteners to attach something, right? They're not just there. So we what we do is we double up the fasteners. Like if we have a fastener to hold the frame together, it also holds the structure in between
sure,
for
yeah, they're
the
all
thing
doing
to
more
mount.
than one job, right?
Yeah,
So,
yeah, yeah.
um,
It gets rid of the welding, right? And the welding for me has always been just a big. There's a lot that goes into welding that it's difficult with
well, it's
people
just
and
especially if you even think about hand welding. I don't think you necessarily made a bad decision. In all honesty, I think I don't know like your total volume or anything like that, and it's not necessarily my business, as far as your cycle rates and stuff like that. But like, um, being able to reliably fasten something is important, right? And you can torque meter all your stuff, and you can at least show that hey, all these things were done on this. The guns are in spec, and these should work, right? Um, when you get to like maybe like in the threshold of fabrication like volumes and you have
yeah,
people welding, are you x-raying these welds? Are you doing any sort of inspection on these welds?
exactly,
So I think
exactly.
it's the same thing with castings, right? There's all
Yep.
because you do so much integration and you have so much hinging on a welded assembly or a big gigacast or something like that. There's pretty expansive efforts to do quality
Yeah,
checks on them to ensure that
we have
this
to
subassembly
X-ray
goes to the line and it's good.
for sure. I mean, we have some high pressure die casts, quite a few, some forgings, and we had to essentially X-ray almost every part
Yep.
on just to make sure, right? It's a swing arm, and yeah, it's costly. I mean, it's super costly, and the frame, the ability for us to do different design iteration was super important, right? We did 8 design iterations within 8 months. It took us from production prototype, from when we launched to serial production and first bite to customer, took us exactly 9 months, right?
That's
And
super
that's
impressive.
super fast for what we're trying to do, and the ability for us to essentially change up design as needed because it was just a bent sheet metal frame was
Yeah, no
critical to
hard
that.
tooling, right? There's no
No,
fixtures
actually,
and
our production prototype was our production bike. I mean,
yeah.
it was literally the same. I mean, we changed mounting locations and all that, but and in terms of our scale, I mean, we've shipped. I think we've been in business delivering now for 10 months, and
Okay.
we've shipped close to 800 units already, right? So it's the 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 scaling, and we've been able to do that with a very small team. I mean, it's around probably 10 people in
That's
production
awesome. Yeah.
to be able to pump that out. It takes our guys about an hour and a half to put a final bike together. So after all the sub assemblies, just one person an hour and a half to completely put the bike together, get it all inspected, and get it out. So relatively fast for this industry and what we're trying to do.
No, yeah, it's super interesting. And like that's impressive. Like I've literally like a question about it, right? Because I was kind of curious. Validation sometimes constrains everything, right? So with and there's obviously some things that you guys bring attention to, like for the instance, like I guess the backbone or the main chassis, right, is being brake bent. And I was curious because there's not a lot of pictures about like the mainstay or the head assembly or some of the other parts. Um, but while you're iterating, at some point, right, changes have to stop, right? Because you're like, hey, I got a great idea. Like, doesn't matter if we don't hit this window and I don't do validation, it doesn't matter. It's next time, right? So it's version
Exactly.
2, whatever you're talking about. So could you speak a little bit to how maybe
Oh
you had
man,
your main pillars and essentially how validating just maybe stopped
we
iterations or anything like
validated.
that?
We literally validated the same time we were iterating, if that makes any sense. So when we started, we validated very quickly. So we have this head tube unit that has been designed, I think, 6 times,
Okay.
right? Just throughout the process. There's two main things where the swing arm connects, and then where the front head tube connects, like the entire front end of the bike, and then where the battery connects, right? 80-pound battery, super heavy. It basically hangs off the frame
Hmm.
because we didn't want to have to like put it inside the frame. We wanted to kind of pop down
Yeah.
an angle. It has wheels so it can roll away. So that it's a cantilever thing that has to hang on the frame. So we focus on those 3 points and we test it right away. The first production frame that we got back, we threw on a shaker, and we shook it at the equivalent of 60,000 miles
Okay.
through a lot of different terrains. Right, we went to a lab, and as we shook, things started breaking off, as we suspect. Like it was
Sure.
the first iteration where like all the FEA in the world didn't account for this type of shaking, right? So swing arms, not swing arms, like the rear fender arms started breaking off. The battery where it mounts started shearing, and then our head tube started getting loose. So
Mhm.
after the first one, we came back. We were able to turn an entirely different frame design, different head tube design within 2 weeks. And we didn't even take the main frame off. We literally
Sure.
went up to the right. So I think it was because we're able to change the design so quickly and iterate versus going out and making a new fixture to weld a whole
Sure.
new different frame. We were able to kind of iterate as we were validating.
Interesting. So,
And
I mean,
then
there's a lot of advantages to failing fast, right?